Hey, it's Clay. Welcome to another video. This is going to be the first and hopefully a series of videos that I'd really like to do on this channel. And this is going to be an attempt to take a look at some very popular guitar amplifier circuits and try to walk through some of the schematics and understand what's going on with them electrically. And hopefully this can provide some insight as to how amps work, how different circuits interact, and just hopefully to share some different knowledge and open this up. This is one of the things that I've really enjoyed about amp building and modding is how cool these different circuits are, and it's very interesting to see how things progress and kind of grow and build. And so anyways, let's go ahead and start this first episode off by looking at the Fender Champ, which is also known as the 5F1. This is probably a good place to start. This is going to be a little bit more of, I'm going to call it hopefully an introductory level. If you're relatively new to guitar amps, I would consider myself still relative beginner, just compared to gentlemen who have over 20, 30, 40 years of experience with these devices. I don't have any formal training, just I like to solder in my basement and I like to read stuff on the internet. So I want to share some of that knowledge. And the 5F1 is a particularly good place to start because it is probably one of the simplest guitar amplifiers that was ever made, and also one of the most DIY friendly. There are a ton of resources out there and kits and just great build threads of, if you want to get started building an amp, this is probably the easiest project to undertake. The overall component count is low, the build is easy, and it's a good sounding amp in the end. So what I want to do is I want to walk through the circuit and kind of identify what you're looking at, what each component does. I want to talk about some potential modifications. I myself have what is a 5F2A Tweed Princeton, which is very similar, and I'll explain where and why. And then I also want to actually take a look at my own 5F2A and kind of discuss how this actually comes into play. Look at some layouts. So hopefully we can kind of understand the circuit and kind of get better at all those things as well. So let's go ahead and get started. To start, I want to focus over here on this left side. Right over here, we've got 1 and 2. These are the inputs. Input 1, input 2. The Fender Champ and most vintage style Fender amps had multiple inputs, which is kind of an interesting old design feature. It was not uncommon to run multiple devices into these amplifiers, whether it was a microphone or a harmonica or an electric guitar or a lap steel or something like that. All these different instruments would run into the guitar, which was very interesting. It just kind of created an interesting situation. Now, in more modern amp designs, you'd really only have one input, because typically guitar players buy amps for themselves to play guitar into. So let's kind of take a look at this input scheme. So we've got 2 inputs. Now what's interesting about them is they're not the same. The biggest, this 68K resistor is the same, but what is different is this guy right here. The 1 meg resistor right here is going from the input of number 1, and it's going actually to ground. And so what this is going to do is this is going to actually first does a couple things. It sets the input impedance from the guitar pickups are reading into the amp, but it's also going to, with these resistors here, change the way that the circuit is operating, and it ends up that this input number 2 actually has about a 50% cut in signal. So this is going to be your low input, this is going to be your high input. So big difference right there. If you're going to only build one input, I would recommend going off of this number 1 here with this typical 1 meg resistor. Next, let's look at these 2 right here. These 2 are joining together, and they're going to be feeding the first part of this tube. This is actually the grid of V1, which is a 12AX7. We'll get to that in a second. But both of these resistors are actually joined together in parallel, because you've got this connection right here. So the signal is actually running, even if you're just in input 1, it's running in parallel, which is going to cut that down to 33K ohms of what the signal sees as a resistance. So this value is important from the perspective that it actually helps to kind of attenuate some of the really high frequencies that can come into amplifier circuits. This isn't such a big deal with guitars because our pickups don't really produce stuff much past our hearing range, but with certain radio frequencies, this can be a really big deal to cut out some of that. So this is the first stage in the amp, a 33K input resistor to kind of help remove that. Now you can actually, I'm gonna come back to this in a second later. Let's just keep walking through them. The next, so we've got this first stage. This is a triode, and this is of the first tube, the 12AX7. Now a 12AX7 is a dual triode, meaning that it has two tubes into one envelope, so it's basically a 2-for-1. And this over here is triode number 1, and then this is triode number 2. We've got the signal coming into the grid right here. Now we have on the bottom side, we've got the cathode. Now this tube is cathode biased, and that is biased by this resistor right here, which is a 1500 ohm or 1.5K resistor, is going to bias that cathode. Now one thing that's interesting to note, point of, I guess, uncertainty, there is no capacitor here running in parallel to bypass this resistor. Many triodes stages will have that as a part of the amp design. But this schematic does not have that. Now I have seen 5F1s that have this capacitor, and actually it's very, very common in many Fender amplifiers to have a bypass capacitor there of about 25 UF, but this one does not have it. And so what this is going to do, as I said, it's going to bias the tube. It's cathode biased. And then this is going to ground. Now on the top we've got the plate. Now the plate is important for a couple reasons. First of all, the signal is coming into the grid and it's actually leaving this triode on the plate, so coming kind of in this direction right here. But additionally, we also have this wire coming right here with this 100K resistor, and this is actually providing our B+ high voltage to this triode. So if you know how a tube works, and if not, I can just kind of discuss it very, very briefly. We have this huge, this is 450 volts, very, very high voltage signal coming almost directly from our power supply from our rectifier. And it's going to be coming through here and providing a very, very strong voltage to the plate of this tube, and that kind of acts as a vacuum that current typically flows, and so it's going to flow towards this very, very positive voltage, and that's going to what's going to generate our amplification. And this 100K resistor right here is what's going to, I guess, determine the rate at which that this is a very common value for this type of a plate situation to supply this B+. Now we come to what is a capacitor. This is a 0.02 UF cap. This is a coupling capacitor, very important. The value here is going to be very powerful in shaping the EQ. 0.02 is a relatively, I'm just going to call it a neutral value, but certain amps might have, like a Fender 5E3 Tweed Deluxe will have a 0.1, a very large value. What that's going to do is increase bass. Then alternatively, you could have even smaller, a 0.002 value capacitor, and what that's going to do is cut bass. So that in more of a modern high gain type situation, you could actually, in more of a modern high gain situation, you would want that to tighten up the bass because you're going to be cascading stages together. Then from there we actually go into what is going to be the volume control, which you can see right here is this 1 meg. This is a potentiometer. You can see the input is coming in from here, and then here's the wiper setting the signal on, and then we've got the third leg running to ground. This 1 meg, this is our first kind of ability to control the signal. So we've got our first triode here on the left, and then we've got our second triode on the right. This is basically all that is standing in their way to, if you crank this bad boy up, you're getting a lot of distortion, and if you turn it down, you get a nice cleaner signal. And so this is important for that reason. Also, this is going to provide a grid leak for our second triode, and so it's going to help kind of attenuate the signal going in there. So that brings us to this part of the circuit where certain, like the 5F2A Tweed Champ or the 5E3 will also have a tone control, And so if you want to insert a tone control to your 5F1, this is the place to do it, around this volume control here. So now we reach our second stage of our preamp. We've got the second triode, 12AX7. Very similar to before, where we have this, this is our cathode, biased by a 1.5K resistor. Again, no bypass capacitor. But an interesting feature is we have this line right here from this 22K resistor, which all runs all the way over here to our output transformer, or speaker, and this is going to provide some negative feedback. So the negative feedback in this amp is actually inserted here at the second triode cathode. Alternatively, up on the plate, very almost identical to triode stage number 1, where we've got this 100K resistor right here and this 0.02 capacitor. Again, providing our B+, and then this is going to be our coupling cap, helping to shape our low end. Good stuff. Moving on, this is a single, preamp valve, so that this is basically the end of our preamp stage in our amplifier. And now we move to a power section. Now we have, again, a single output tube running in, just a Class A operation. So we don't have any sort of push-pull going on, so we don't have a phase inverter. We just run straight into the output tube. So moving into the grid of the output tube, we have our grid leak resistor right here, 220K. This is also a location where you could turn this into this type of, if you would just mirror that right here, you can see we've got 0.02, 1 meg going into the grid. Well, we could do a 0.02, and then instead of the 220, you could do a 500K or a 1 meg going into the grid of the output tube. That could be a master volume location. So then we run into our 6v6. Some interesting things to note. We actually have a 470 ohm resistor on the cathode that is going to help bias this bad boy. And then we also have a 25 UF bypass capacitor. The first time we've actually seen one of those in this amp, which is interesting because these other stages don't have it. We'll come back to more of that later. So then from there we have, this is not a triode, this is a pentode. So we actually have, I believe this is the screen grid here where this signal is inserted, the B+. I could be wrong, please correct me. And then again we've got the plate which sends the output to our speaker, our output transformer, and then to our speaker here. So that is it for the power section. Again, a very simple power section. Not a lot going on. Let's move on down. We've got these components right here. Now what these are going to do is they're going to receive the signal from right here. This is going to be our 5Y3 rectifier tube. It's providing this very high voltage direct current. We got 450, 450, 450, and this 16 UF cap, this 8 UF cap, and this one, these are all going to be our filter capacitors. So these are going to filter out some of the voltage. The voltage is coming into the wall as this nice 120 cycle alternating current, looks like that. Then the rectifier tube changes it to direct current, which is basically going to slice it in half. You're going to get rid of all this stuff. And it's actually going to go up, well, it depends what kind of wave it is. I'm not going to get into that. But then what these filter capacitors are going to do are going to try to smooth this out so you don't have these humps right here. So you want to have just a very even direct current without any sort of humps. And as you'll notice, we actually, the amount of capacitance, we keep increasing it as we move this direction. That's because over here we've got our preamp V1 and V2, and those are very susceptible to ripple, hum, and causing lots of noise problems. So the filter capacitors here are responsible for smoothing out that hum and providing a nice clean power signal for those tubes. We also have these resistors here. They're going to be our step-down resistors, actually going to be reducing the voltage a little bit as we move. A 6v6 requires more voltage than a 12AX7, so that's how we're going to accomplish that. And then we've got our 5Y3. This is our rectifier tube. You can see it's receiving voltage right here from our power transformer. That's this bad boy right here. The power transformer is receiving the signal from the wall, transforming it, and then we've got this rectifier tube, signal's coming in, and then it's going out, comes in alternating current, leaves it as direct current, and that's pretty much it. So that is the circuit breakdown in a nutshell. Let's talk about everyone's favorite topic, mods or modifications. Let's just kind of walk through it, and we will see what we see. So first up, let's talk about this input section. I think that the second input is a little bit redundant. So when I built my amp, I actually just had one. So I got rid of this bad boy altogether, and I just used one input stage. So I actually removed that input. I just found it to be redundant for my purposes. I do not need two inputs. It's totally up to you though. Whatever you prefer to use. If you want to, certainly go for it. Now, in doing so, that also means that I needed to change this resistor here to 33K. Because we no longer had this parallel section up here, these two 68Ks, so I just went to a single 33K. Alternatively, you could keep the other 68K and just route it to this location instead. That would work just as well. But it is possible you could actually remove this resistor or reduce it to 20K or 10K or just clip it out entirely. If you ever have problems with radio oscillation, you may want to put it back in, but removing it will increase the current flow to the grid and kind of give you a little bit hotter signal. So if you're looking for a little more gain, this might be a place to start. Now the next thing I want to talk about is this guy right here. This section, this is going to be our cathode. I actually would install a cathode bypass capacitor here. So that's going to look like this. We'll do a 25 UF cap to help bypass that 1.5K resistor. And what that's going to do is 25 UF is actually a pretty large value. And that 25 UF basically means that the entire guitar signal is going to bypass this resistor. So that's going to, number one, it's going to increase gain, and it's also going to just provide, the full frequency boost to this signal. It is also possible, and actually one of the things that I would recommend doing is experimenting with a lower value bypass cap. If you find that the amp has too much bass and low end, this is a place where you can trim it. You could do something like 2.2, or you could even do a 1 UF. A very typical value that you might also see is 0.68. This is actually taken from a Marshall Plexi bright channel. So a really cool mod there to give you a little more gain, but also to tighten up some of the low end in an amplifier that can get a little bit out of control. Next thing to look at would be this resistor right here. You could actually increase that value if you want. You could increase it up to 220K, and increasing the resistance there is actually going to give it a little bit more gain, a little bit more output through the signal. 220K again was taken from a more of a Marshall style preamp, so you could bump that up a little bit if you'd like. Next are going to be these coupling caps. Again, I mentioned this earlier, but a bigger value, so if you went to like 0.047 or 0.1, that would actually allow more frequencies through, and that's going to cause more low end. So like a Tweed Deluxe 5E3 is going to have a 0.1 coupling cap, so lots of low end. Alternatively, if you want to clean some of that up, you could lower this to like a 0.01 or 0.002, 0047, something like that. So that's going to help actually tighten up and remove some low end if you feel like you've got too much. Next up, we have this volume control. Now, I wouldn't change anything to the volume control itself, but this is a good location to put maybe a bright capacitor or also a tone control. A tone control is a nice addition right in this location. You can do a Google search for like a 5E3 Tweed Deluxe or a 5F2A Tweed Champ Princeton, and just copy that tone control. There are other ones out there as well. Just a lot of different choices you could put in here. Moving on to V2, same thing where you could put a bypass capacitor here. It's going to do the exact same thing as mentioned before over here. Same choices available. Same thing with this resistor and same thing with this capacitor as was stated over here. More than capable of changing those values and getting those same things. This right here, you could put a master volume, which I believe I had mentioned, so you would just want to wire it just like this, where you run into this 1 meg pot and into the grid. Just mimic the exact same thing. It's basically the same control, just later in the circuit. And what you've kind of basically done with these modifications here is you have actually mirrored what you're doing, you know, when you run into the grid here, and then you have all this going on. You just mirror the exact same thing into V2, which is kind of an interesting choice to make. Another modification that I really need to mention right here is this bad boy right here. This is probably one of the most important modifications you could make. That's to the negative feedback. Negative feedback, what it does is it actually takes some of the signal output from the power section, so all the signal running through, and it actually loops it back to an earlier part, and it actually creates an inefficiency. Now, that will actually reduce gain, and it will compress the amp a little bit more. It'll flatten the frequency response. So you can actually put a switch in here, one, and just have the other end be totally lifted, and then the other end runs to this resistor. So when the switch is up, you have the stock negative feedback, and when it is out, then you actually remove this entirely. So nothing is fed back into the circuit. You have a much more efficient all the way through to the speaker. And that is actually going to increase gain and kind of just give you a little bit more of an overall raw, just kind of a crunchy, raw type sound. And, you know, having it on a switch is a really nice mod. You can also put a variable resistor pot in line with this as well. So maybe like a 100K pot or a 250K pot. So you could actually have varying amounts of negative feedback. And what I would actually probably do is I would reduce this to maybe like a 10K resistor and put that in line with like a 100K pot. So when you turn the pot all the way up, you have 110K resistance. That's a lot, resisting negative feedback. So it's basically like removing it. But then on the bottom end, you actually have 10K, which is even less. I'm sorry, even more negative feedback, even less resistance to the negative feedback. So that's going to even clean it up even further. And then you have everything in between. It's a really neat mod to do. Another thing you could do is, just to mention, you could actually put an additional 16 UF filter capacitor right here. That's just going to help tighten up the low end and more importantly, kind of reduce some of the hum and help the filtering out. Again, the 5F2A has that. Really nice mod. And so, yeah, that's going to cover some of the basic modifications to this circuit. You know, basically all the values that I mentioned you can play around with. You can put them on switches. You can turn some of them into pots and just accomplish a huge wide variety of tones with this really cool, simple little amp. So I hope you guys enjoyed this look at the schematic. Definitely please let me know if you have any thoughts about amp circuits that I should do in the future. I would really love some input. I've been taking a look at a lot of different amps and really am enjoying this process. So please let me know your thoughts, and I'll see you again soon. Bye.